Dear colleagues, the second part of first unit is analysis of bars of composite sections. A bar made up of two or more bars of equal length but of different materials, readily fixed with each other and behaving as one unit for extension or contraction when subjected to an axial, tensile or compressive loads. It is called a composite bar. For the composite bars, the following points are important. The extension or contraction each bar is equal, hence the deformation per unit length is equal. The total external force on the composite bar is equal to the sum of the load carried by each different materials. Therefore, the stress developed in the bar 1 is equal to load carried by bar 1 by area of cross section 1. Like that, the stress in bar 2, the total applied load capital B is equal to the load applied on each materials. The strain on the first material is stress strain in first bar by the Young's modulus of the material. Then the strain 2 is the stress in second bar divided by the Young's modulus of bar 2. Therefore, sigma 1 by E1 is equal to sigma 2 by E2. The modular ratio, the ratio of E1 by E2 is called the modular ratio of the first material to the second. Okay, by using the simple formulas, we can do numerical problems. A steel of 3 cm diameter is enclosed centrally in the hollow copper tube of external diameter 5 cm and internal diameter of 4 cm. The composite bar is subjected then to an axial pull of 45 kN. If the length of each bar is equal to 15 cm, determine the stress in the rod and tube, the load carried by each bar. Take the Young's modulus of steel is 2.1 into 10 power 5 Newton per mm square. For copper, the E is 1.1 into 10 power 5 Newton per millimeter square. First, write the data given and convert all the units into Newton and millimeter. First, we have to find out the stress developed in the steel. Stress in strain is equal to stress in copper. You can use the stress and Young's modulus equation to find out the stress. And the total load will be the load on steel and the load on copper. The load is nothing but stress into area. From that expression, we can find out the strain. The load carried on each bar can be calculated using this. Load is equal to stress into area. The stress is already computed for copper and steel separately. Then we can find out the load carried by the each bar. Okay, do the next problem. If you have any doubt,